My name is Aaron Reedy from DataClassroom. I'm thrilled that you've decided to join us on this afternoon. Um, our topic is graphing as the gateway to data analysis and statistics. And this is a viewpoint in the science and math classroom that I've come to hold over my years teaching at different levels. And it's one that I've explicitly built the classroom app to help with. So this idea that graphing is a gateway to statistics is not necessarily a unique view of mine, but it's one that I champion whenever I get the chance, and I firmly believe in. And I really believe it's the right approach, whether you are teaching middle school students or whether you are teaching graduate students. Beginning with graphs and using graphs as the springboard to all the complexity of analysis can be a very effective way to go. So with that, I want to give you just a little bit of backstory on who I am and where I'm coming from. If you're like me, you're always just a little bit skeptical of any PD presenter, and you just want to know how do you know how do you know what you're talking about, right? How do you know that? How did you come to know that? And I'll say that DataClassroom was really born in a classroom on the south side of Chicago, where I taught for 7 years in the Chicago public schools. And that's where I really got an idea of what the need was for a data tool, what my ideal data would look like, what were the ways that I wanted to work with data with my own students, and how I got in touch with the problems. And then I left the classroom in 2012 to begin a PhD in evolutionary biology. And for 8 years, I was primarily a researcher studying natural selection. I worked with wild lizard populations in Florida and in the Caribbean on small islands. But while I was engaged in that work in my scientific career, I was mentoring teachers through a program called Evolution Education. And I was approaching that with my own experiences coming from the classroom in Chicago, but then also my career as a scientist had exposed me to all of the pro level tools for working with data. And it really struck me as kind of surprising that, I had kid versions of a lot of different scientific equipment in my lab, things like, microscopes made for schools, digital balances made for school labs, but there was no real kid-friendly version of the digital tools that I used as a scientist to analyze my data. I had gotten by with Excel. A lot of people use Sheets these days, but those are not really tools meant to teach the concepts related to data analysis. And so that's when I had this idea for building DataClassroom. And I partnered with some top engineers, convinced them that this was a project worth their time. And we started building DataClassroom about 3 years ago. Fast forward to where we are now, it is now my full-time job. We have over 54,000 teacher and student passwords created on the site. And over 9,000 of those passwords are teachers who discovered DataClassroom. So I'm thrilled to find out that it was just not my pet problem, but this is also an issue that a lot of teachers were having. So the structure of the workshop today is going to really revolve around a 3-step strategy for using graphing as a gateway to other data analyses and statistics. And the first step in there is begin with graphing. And I think especially this almost becomes more important the higher the level you're teaching, because it's quite natural to begin with graphing if you're teaching 5th or 6th graders to analyze data. But I think people can sometimes lose sight of this when they're working with older students. I firmly believe this is the place to start, even if you're teaching graduate students. So you want to plot your data out in possibly more than one way before you start applying any mathematics to it. And you want to have a pretty good idea of what your data are telling you going into those analyses, because just like in simple 3-digit multiplication or 2-digit multiplication, we frequently use estimates before we do calculations, and statistics should be the same way. You should have an idea of what conclusions you're going to draw after you've made a plot, but before you've applied any mathematics to it. So begin with graphing. And then two, focus on the question. So focus on what you want the analysis to tell you, what you want to ask of your data before you get started with any further analysis after the graph. And actually, this focus on the question could have been number one, because this actually will dictate how you make a graph. So number one, begin with a graph. Number two, focus on the question. And another benefit of this focusing on the question is that this will actually allow you to teach critical thinking along the way. As you're teaching the mechanics of graphing or data interpretation, you'll actually be strengthening critical thinking skills, and it can really bring clarity to the work that you and your students are doing surrounding graphing and analysis and statistics. And then number three is the third and final step, is move on to more advanced analyses through graphs. So use these as a jumping off point to go into descriptive statistics. Use these graphs as a jumping off point to go into even inferential statistics or any kind of visual analysis that's following. This is what you want to do. So this three-step strategy is what I'm going to focus on. And I'm going to show you three examples with three different data sets that are all available in the DataClassroom resource library. So you can work with any of these data sets for free. And then I will also show you the DataClassroom Graph Wizard, which is part of the licensed version, although you can start a free trial of it right now if you want to play along at home as we're doing this. And if you create a free account on dataclassroom.com, you can log in. And then when you go to use the Graph Wizard, it will ask you if you want to start a free trial. All you have to do is click yes. It doesn't ask you for any additional information. No information required about your school, no credit card required. You just click yes, and it will start running. If you wish to extend that trial at any time, just drop me an email and let me know. I'm always happy to extend it for someone that's evaluating DataClassroom. But I would encourage you to start a trial and play along at home as we go through some of these examples. Okay, and Blake, feel free to interrupt me at any time if there's a question here. Okay, so first I want to share what I consider to be a fantastic teacher resource. And as I mentioned, I left the classroom in 2012, so this didn't exist when I was in the classroom. But I wish that it had. It's a fantastic resource, and it's inspired a lot of the work that I've done in the digital tool on DataClassroom. It's something called the graph choice chart, and I will definitely include this in the follow-up materials to the workshop. This was something that was first published in the Science Teacher in 2014. So I believe the Science Teacher is NSTA's journal that has a lot of content contributed by practicing teachers as well as education researchers. And this is really a great visual for this idea of focusing on a question when you're working with data, because it asks students to think about what is the question you're exploring, and then it challenges them to write their question as a complete sentence. And then from there, it leads to what are suitable graph options. And it starts to get at this point that there is not one right answer when it comes to which graph should I use. And this is a question you can get asked by students a lot. And one of the most difficult things about working with data is you will often find yourself in a situation where there isn't one right answer. And it depends on the subtleties of what exactly are you trying to show. That's going to help dictate what decision you make about which graph you use. But this graph choice chart, I think, does an excellent job of laying out this logic. Since it came out in 2014, I've seen this redone by a number of different sources on the web, some adding new wrinkles, some adding new graph types. But the basic idea is a really good one that you should ask students, what kind of question are you wanting to explore? Can you state that question And then once you've done that, here's the appropriate graph choices and options for displaying that visually. In DataClassroom, we've taken this idea, and my co-founder and co-creator Dan Temple, who is an engineer, this is something we really hashed out over a couple of months as we started to really think about, okay, if we want students to begin with focusing on a question and starting graphing and analysis with a question, what are the sort of main categories of data questions that students might want to show? And we've got this broken up to proportions, change over time, variability, comparing groups, and relationships. So we think most questions that your students are going to be tackling, whether it's with lab data or it's with data from some other source, or even if it's just looking at a graph and trying to decide what questions can I answer with this data that I'm looking at visually, it's going to come down to these kinds of questions. And so I just kind of want to linger on this slide for a bit and give you a chance to look at some of the examples. But you can see underneath each of the main headings, there's a question that sort of asks, what do you want to show? Do you want to show how data are distributed among different categories? Well, that's proportions. Do you want to show how something changes over time? That's changes over time. Do you want to show the variation or the shape of the data? That's variability. And variability might be a word that your students aren't initially familiar with, but they might be able to grasp onto looking at variation or shape of the data. Comparing groups, right? Are you trying to compare things in terms of some numerical measurement? And then relationship. This involves two numeric variables. Are you looking for how one might be related to the other? And then you see below those, there's examples, and we've tried we've put a lot of effort into trying to make sure that's in as plain a language as possible, so that kids are able to take what they have in their head, their idea for their question, match it up to one of these categories. Just gonna have a sip of coffee. See if there are any questions at the moment, Blake.
The question that is put to the group, I'm going to encourage anybody to raise their hand or message me or Aaron, is just which of these 5 categories has been most difficult in your experience with your students?
Yeah, that's a good question. I would love to hear some of those answers in the chat for sure. I know my definite answer when I was in the classroom, I would have said comparing groups, because I think to do it in a rigorous manner involves this concept of variation, and so you can see a difference between groups, but then the question immediately becomes, well, is that a relevant difference given the amount of variation? And actually, one of the examples I'll show will go into that a bit. So we're going to work with 3 examples today. These are examples that are going to illustrate sort of three graph types that I think are used commonly in both middle school and high school. And this is a line graph. This is a frequency plot, which is frequently called a bar chart. And I personally don't have a problem if someone calls it a bar chart, but the term bar chart can be a bit vague and can sometimes lead to some confusion. And then the third example on the right is showing an example of a graph comparing groups. And what I've got shown there is a jittered dot plot, as well as a box and whiskers, as well as dot and error bars highlighting the means. And I'm going to show some examples of how those can be used. I'm also a big proponent of using those kind of visualizations, which graphically illustrate variation, as opposed to just showing a bar where the height represents the mean. I think that can often be misleading. So we're going to go through these 3 examples. So I'm gonna stop my screen share for just a minute, and then I'm gonna open up DataClassroom, and I will screen share again and go through each of those examples.
And Aaron, while you're switching your screen, I'll just share an observation from Tracy, which is just that students often have trouble deciding when relationships are represented in a graph that they didn't already know existed. And so I think one of the things we can think about as we go through these examples is how to actually make graphs and assets an asset for students to be able to better understand the data they're working with.
Yeah, absolutely, absolutely. One thing in sort of thinking about this too, I always found that students' abilities to interpret graphs outstrip their ability to communicate with graphs. And I always make the analogy of, like, if you've ever worked to learn a foreign language, you reach a point where you can understand things and you can read things more proficiently than you can actually formulate sentences at the speed of conversation and get words out. And I think it's the same with graphs, where data analysis and interpretation is more akin to that skill of reading, but the ability to take a raw data set and know what you want to communicate and know exactly the graph you want to make to do that before you draw it out, that's sort of akin to speaking that foreign language. And so I do think that's an area where students will need more scaffolding. I'm logged into the DataClassroom web app, and I just want to, if you haven't been here before, this big help block on the dashboard is an excellent place to start, where you can get help on using DataClassroom for lesson plans, for graphing, for working with your own data, or for doing statistics. But I'm going to actually just jump into the resource library via this big button up here. I also want to point out that the Browse tab opens up a menu where you can see your data sets and files you've worked with before, and you can also see the resource library. But I'll go to the resource library here. The resource library has data sets, many of them with complete lesson plans, that are in the library. These are all available free for you, so you can look at these lesson plans. You can work with these data sets for free. I'm going to search for this Thanksgiving data set, and it's built around this question of, does Thanksgiving dinner get more expensive every year? And it's an activity built to compare a line graph versus a linear regression. But you can customize this and use this in any way you want. If linear regression was above the level of mathematics that you wanted to integrate in your class, and you just wanted students to look at a simple line graph, I think you could do that very easily here. And you could move to a linear regression from here. So for each of these three examples, I'm going to kind of show, here's how you would do the basic graph, and then here's how you might extend it a little bit further into a more complex analysis or statistical analysis. So I'm going to use this flow up here where there's preparation, visualization, and statistics. And I'm going to click on graph. And I'm going to open the graph wizard. And this is where, if you do not have a DataClassroom license or a free trial, it will ask you if you want to start a free trial. If you want to follow along at home, you just click yes. But I'm going to open the graph wizard, and you can see it's asking your student this question. And I think whether or not you're using DataClassroom or not, even if you were doing this as a 100% pen and paper, no digital activity, I think you would want to ask your students, what are you trying to show? And I think it could be very productive to break it up into these 5 categories. This particular data set, we're interested in a change over time. We want to know, has the price of Thanksgiving dinner changed over time? So I click yes, and it says you're investigating how numeric variables change over time, or how a numeric variable changes over time. And then it asks you, which variable represents time? And I can choose, I only have 3 variables in this data set. Year, which is coded as numeric, it represents time. And then what do we want to see the change? We have 2 options here. We could look at the real cost in 2019 dollars, so cost adjusted for inflation, or we could look at the nominal cost. I'll look at the real cost. And then it gives us one more question. Are we looking at how several things change over time, or are we just measuring one variable? We're looking at one variable right now. And then so from here, we could say, no, I'll do it myself. If that was all the scaffolding a kid needed to say, I just needed to see what graph type it was. Or you could say, yes, show me the steps. And then from here, all the steps are listed. And if I click go, it will do those things. So switch to graph view, clear existing graph, select graph type, add variables to the graph, place variables on the axes, and then add connecting lines. And I've done that, and it's made my graph for me. I can show you, if your students were doing that from scratch without the graph wizard, if you were just using the free version of the program, that could be done by just coming into this graphing view and, adding real cost and adding year to the plot. And that's it. So it's just those 2 clicks once you're in the graphing. And then this connect the dots option over here. So it would look like this at first. And our control panel is built so that options appear on the right as they might become relevant. So you could add your connecting dots here, and you've built a line graph. And if you're teaching a 6th grade class, it might be enough to just say, yeah, we just wanted to build the line graph. We wanted to have a discussion about how things changed over time. Students could look at this graph and say, well, in the late 80s, it looks like prices for Thanksgiving dinner really fell kind of rapidly. And then they sort of stayed at a lower level for, roughly a 20-year period. And then they had a little increase. And then in the last 10 years, they seem to have been dropping. So you could have students have a conversation like that. If you wanted to add a different kind of analysis to this, you could, instead of connect the dots, you could do a regression line and say, okay, what has been the trend over time? And this is a little bit of a higher level concept in talking about a line of best fit and talking about how it's minimizing the squared differences of each of the data points across the whole graph. You could even, depending on what level you're at, you could move up and do more complex regressions instead of a linear. You could do a cubic regression like this, which allows for a more curved surface. But this, I think, even if you're going to, have a lesson where you're talking about cubic curve fitting and you're at a higher level math class, you still want to begin with the basic graph, talking about what these things are doing. And again, just that basic strategy, I think it works no matter what level you're at. Start with the graph and then build from that graph. We'll go back to the connect the dots here.
Aaron, I've got a couple questions from the audience. One that's pretty timely, and that is there a space where students can write their interpretations of these graphs?
There is. So there's a couple of different things you can do here. One, you can go into the appearance menu, and while I'm here, I'll show some other things too. But first, just to answer the question directly, if you wanted to, say, add a caption below the graph where you put some kind of interpretation, you can click that add caption, and then I can go over here and I can start typing a caption in there, and that can be displayed below the graph. I can also add a title above the graph, because sometimes titles can be a summary interpretation of a graph. And again, same thing, I just click on that to start editing that. You also have the ability within DataClassroom to add attachments. So you could put a whole Google Doc within here, and your student could save that file. So this paperclip up at the top, if I click this up on the white bar, I can add an attachment. And I don't own this data set yet. So your first step is always to make your own copy of this. This is the DataClassroom owned copy. But now I can go up when I've got my copy of the file, and I can add an attachment. I can take a link to a Google Doc, and I can paste that link in here. That Google Doc will then be linked to this data set in DataClassroom, and I can edit it from within there, and it will open up the Google Classroom copy, and I can make changes in there. So it's fully integrated with a Google Doc that way, and that's a place where students could add some interpretation. You can also, if you wanted to add the graph to a document, the camera in the upper right, if I click that icon that's in the upper right corner of the graph, it will load this up on the clipboard, including my caption that I wrote underneath the graph. I can copy, and now I can paste that into any document that I'm working on, whether it's Word or Google Doc. So those are ways that students can make interpretations and then record those in a digital environment. Another thing I wanted to show you, the appearance menu is quite expansive. You can do all sorts of things like change the color of lines, change the color, like here, I can change my regression line. You know, you can do all sorts of things where, or I can change the color of my points. Sorry, that's a regression line. I have a connecting line up, which is different. If I change my point color, you can see how I can change points. But you can also do fun things like instead of representing data points with points, I could choose from 3,600 emojis, and I'll maybe, let's see if there's, pretty sure we have, yeah. So here's a turkey, and since this is Thanksgiving, you know, I can make all of those data points turkeys, and I can make those a little bit bigger so you can actually see those. So you can do some fun things just to have a little bit of fun and have your students take more ownership over the images they're creating in there. So,
and Aaron, how many of these features on the graphing that you've gone over are part of the free version?
oh, all of the graphing features are part of the free version. Yeah, all of those. Yep.
Good questions in the chat too, if you don't mind me interrupting. One of them was, how do you work with different date time variables in different formats?
Date time. Well, first I want to start by saying working with date time formats cost me about 8 months during my own PhD. So I will just say that working with dates can be tricky. But we have helps built into DataClassroom when you're uploading your own data to help with issues of data formatting. And dates are a tricky case. And what we recommend is converting dates into a numeric variable. And this is the same whether I'm working with a professional data scientist, a PhD student, or a kid, right? It's so the easiest thing is if you can convert those into, like, say the beginning of your study is day 0, and then each date in there just gets a number, you know, in sequential order going up. If you can convert dates to a numeric, which is what I've done here in this data set with years, I've instead of having dates as categories or leaving them in as calendar dates, they've just been converted to these numbers, you know, 1,985 through 2020. And so that's my recommendation. That's also my recommendation when I'm mentoring kids around the country in science fairs as well. So I think converting dates into numeric variables is usually the easiest way to go.
Well, and Aaron, you alluded to something too, that like some of the questions in chat are asking about introductions or guides to begin using DataClassroom. And you mentioned the graphing wizard and then some of the processes that DataClassroom helps with students as they format their data. But would you mind talking a little bit about some of the new introduction to DataClassroom features?
Yep. So if you look up on the purple bar, there's two little icons up here, a light bulb and a question mark. These are both places you can go to get help. If your question is pretty simple of just where is the button to do this, your first option might be to go to the light bulb, which just pops up a little tour, and you can move this around. You've probably seen this kind of thing on a different number of web applications. I can make it go away. I can bring it back with the light bulb at a later date. A more extensive help menu and a little bit more open-ended is if you click this question mark up here, it will open up userguide.dataclassroom.com, and you can search for help in the search bar by category. You can also, you know, click on these categories and you can see things like getting started, and it'll start you at the beginning, but then it also lets you see this menu at the side. So like if I click on graphing, you can see all of the different topics that are related to graphing at the left. And they're all set up like this, where there's pictures of where the buttons are, you know, what the explanations are, what we're talking about. And there's frequently short YouTube videos within there as well. So, and again, to get to that, that's just the question mark up on the purple bar. Definitely recommend having that at your fingertips while you're checking things out.
And Aaron, one last question while we're here on the graph. And I apologize if you don't know the answer to this because I don't know it. What is the image size when you copy the graph to the clipboard? Like how big could you realistically use the picture for? Like, is this something you could use as part of a science fair presentation? I
need Dan, the engineer here. He'd be able to tell you exactly. I will say I've seen DataClassroom figures on science fair posters, even some science fair posters that have made it all the way to ISEF, which is a national science fair competition. So I believe they look okay on posters when enlarged, but I do not actually know what the file size is off the top of my head. If you email us that question, we can answer it though.
Yeah, Brian, we'll get back to you on a more specific answer. But thank you for asking. That's a great question and something we can think about as we keep working on the site.
I'm going to move on to another example, but if there's another question, feel free to ask it as I switch to that. So I'm going to X out of this data set, and I'm going to go back to the resource library. And
Aaron, before you get the next example set up, do you know where we are in the plans to be able to offer DataClassroom in Spanish?
Quite honestly, we need to add probably one more member to our team. We do actually have some contractors lined up to help with the translation, but it's a pretty big undertaking, and we just don't have the bandwidth yet. But I will say the technology on the back end is already set up for dual language, because the lead engineer on our project, my partner Dan, he lives in Denmark, and so he does some of his thinking in Danish, and so he's built it from the very beginning to accommodate 2 languages. So we're just waiting for just really for us to have enough resources to be able to undertake that. All right, and I'm going to open this data set, which is called Snapshot of Biodiversity. This is something we made in collaboration with a group called the Morpho Institute, which takes teachers on some really cool experiences in the Amazon. And this is camera trap data collected by scientists at George Mason University, and it has different species. Each row in the data set is a different photo taken by a camera trap set up at a salt lick in the Amazon. And so the variables are simple: which salt lick were they at, what's the scientific name, and what was the species name for each observation. And if the basic question in this activity is, well, there's a couple of basic questions, but the first one is just, is there a difference in the frequency of these animals that visit the salt licks? Is one of these more common than the other? So to kind of go through this through the graph wizard, this is a question of proportions, if you wanted to use this one as an example. And so it's do you want to show how the data are distributed among different categories? And the different categories are I believe 5 different animal species that were recorded on these camera traps, all mammal species. There were other animals that visited the camera traps, but only mammals are recorded in this data set. So this question of proportions and which variable, I'm only selecting one variable here. I could do this with the scientific name or the species name. I'm gonna do it with the species name. I could also ask the question of, was one of the salt licks more popular than the other ones? Was it visited more frequently? That's a different question, but also a question of proportions. But for this one, I'm gonna check species. And now here's a situation where students are presented with 2 options, and both of these are completely okay. A pie chart, a bar graph, either one is acceptable. I'm going to go with the frequency chart, the bar graph, and I can show you how to move between the 2 of these as well once we make the graph. So then I'll go to set up the steps, and as I click these steps, we get the graph made. I want to point out that the way these scaffolds are designed to work is that as your students become more familiar with the tool, they will reach a point where they will say, this graph could have been made in actually just really a single click, right? All I had to do was click species and it makes this graph. And once students get familiar with DataClassroom and they're familiar with the question, because again, we don't want them to skip that point. We want them to think about what is the question that they're asking. So in this case, the question is like something like, was one of the animal species more common than the others, or were any of the animal species more commonly observed than the others? But once they know that question and they're familiar with the tool, they can make that graph really quickly. If they don't need the scaffolding, you can encourage them to skip the graph wizard and just go in and make that. Looking at these data, it's pretty apparent that the red brocket deer were much more frequently sighted at at the camera traps. And, this can get into an interesting question of, why is that? Were they just the much more common animal in that part of the Amazon? Are they more attractive to the salt licks? Do they do repeated visits where the other ones just do single visits? So, there's a host of questions you can get into about that. But the basic conclusion that you can draw is, yeah, no matter what the reason, red brocket deer are visiting that trap more frequently. And so you could stop here if you're working with younger level kids, or maybe that was all you wanted to get out of them interpreting this graph. However, if you wanted to go a little bit further and you wanted to ask your students a statistical question like, hey, is it possible that the red brocket deer in this data set just turned up more frequently based on random chance? And I mean, I can tell you this is pretty stout statistical effect. It's a pretty big sample size. You can see those 800 visits. You know what the answer is. But if you did want to make a foray into statistics, this button over here by the appearance menu is going to help you. Again, pedagogically, we want to launch the more sophisticated analysis from the more simple graphing. And so once I've got my graph set up and I click that button, it will allow me to analyze my data with the hypothesis test, and it will tell me what the appropriate test is based on the graph. This is set up for a chi-square goodness of fit test. So if I have any AP bio teachers out there in the audience, you probably knew that already because it's such a central part of that course. But you can see it's because you had a single variable on X that's categorical with greater than one value. This is asking a distribution question. If I click calculate, you have the option to, if you want to set an expected count in your null hypothesis for something other than an even distribution, you can do that. But the default is going to assume an even distribution. So what this is doing is this is a mathematical test of saying, hey, are these counts, are they violating what we would expect to see if this was in fact random, which animals were cited at the camera traps? And you can go in and you can run that. Degrees of freedom, you get a chi-square test statistic, you get a p-value. If you want some more explanation, you can click this explain, and it frames the question, right? Is there a significant deviation between the observed counts of the sample groups of species and the expected counts? So this is you're looking at, did your observations differ from your expectations? And you can see where the p-value is on this number line that, yeah, it's as far left as it can get pretty much. They do differ from expectations, and you can play with this and drag it and see, over here, this is no evidence territory. This is little to no indication, but whenever you let it go, it snaps back there. So this might be a way, if you don't want to spend weeks teaching the math behind a statistical test, but you'd like your students to just make a quick foray into testing it, this is a way to do that from the test. We also have a much slower, more in-depth animation showing how the math works behind a chi-square test, but that's a little bit outside of the scope of our topic today. But I invite you to check out the tutorials and the help guide. If you type chi-square into the help guide, you'll be able to see those things. What questions might we have right here, Blake?
We don't have any new questions right now. So it seems like everybody's just been transfixed on your demonstration here with the different species. One question I would have you showed us some of the different features you can change with appearance-wise on the scatter plot. What are some of the options we have here to really change the appearance?
Yeah, well, you can do all in the appearance menu. You can do all sorts of things related to the axis size and color labels and things like that. I will also say that if you go up to the categorical variable that you're displaying, you'll see this little values box right here. And this allows you to set certain settings for those categorical variables. So I can go in here and I can do things like change the colors for each of these. So if I decided I did not want my lowland taper to be gray anymore, I could change it, and well, I'm not going to make it orange because there's already another orange, but I'll make it like this pink color. Hold on, I've got my zoom window in there. So I can make that pink, And then when I click done, you see it lowland taper is now pink. So you can change those things. Some of the other things I showed too, you can add a caption, add a title, that kind of
How
stuff.
about if you changed your mind and wanted to see it as a pie graph?
If you wanted, thanks for the reminder on that. If you wanted to see it as a pie chart, these icons over here show you how to go through different graph types. And so right now you can see the histogram frequency plot is in blue. But if I go to pie chart, now you could see that same data as a pie chart. From here in the appearance menu, you know, I could do things like display the percentages of each animal in there. So you can do that. And if I decide I want to go back to the frequency chart, you know, it's just that button, and I can toggle between the two of those. So you can have a conversation of saying, you know, what did you find different about the way that these two visuals are communicating? Was there, you know, are there any things that you're able to see quicker when you're looking at one visual versus the other? And that's an important lesson to learn about data analysis and graphing, is there's not just one way to do things a lot of the time.
And I can probably send you back away from the pie graph. Can we use the data classroom to show error bars?
You can, and that's a great transition to the third example. And we're inside of 20 minutes left, so let me show that. So I'm going to go back to the resource library. I don't need to save any changes here, and I'm going to open up this data set that's called Cicada Sex Education. So I'm again, all of these have open the lesson plan or open the data set. I've just been opening the data set here. And for this, I'm going to go back to the graph wizard, but let me just set this up. This data set is from a published paper in 2015. It looked at thousands of individual cicadas. The way that I've formatted the data set here is that each population and each sex is its own row. So for each population, they observed males and females. And so each of these got its own row in the data set. And we're going to compare head width between the sexes. So head width for males and head width in females, and ask this question of, is there a difference between these? We could also, with this data set, ask questions about, you know, what affects head width? Is it factors like latitude or altitude or annual mean temperature? We can look at how that differs across three major species groups of cicadas. But we'll go this simple question of, you know, do males and females differ in how big their heads are? So if I go into the graph wizard again, this is a question of comparing groups. So I'm going to click yes for this. And what specifies the group? And again, we could do species group, but we're focused on this question of sex. And then the variable we're interested in is head width. And then here we actually get 4 suitable options for this graph, really two variations of 2 different options. We've got this jitter dot plot or grouped dot plot, and with or without descriptive statistics. And we could also use a histogram to show the distribution with or without descriptive statistics. And I'm a huge fan of the grouped dot plot, so I'm gonna show that one, and that's the one I had in the intro slide showing this example. So when I go into the grouped dot plot with descriptive statistics, and I'm just gonna click do all here, and so you can see it set up quickly. It actually, if you add the descriptive statistics, the default is to show you the mean and standard deviation. There's other options to that, but I'm gonna circle back to this. I'm gonna start with the more simple graph. And this is just a graph that compares males and females. And it's incredibly simple in that it just shows 1 point per data point. And this word jitter, if you're not familiar with this word, jitter is the horizontal spread of the points. And I can control that. I can spread these out. And that's a random configuration. So I could shuffle them. And so you can just see me shuffling the points there. But I'm gonna cut it down. I really like how it looks with that 1 unit of jitter there. But this is how you can make a comparison. And you can pretty clearly see, even if you're not well versed in statistics, you can look like there's a range for both males and females, right? It's not like they have one head width. They vary. There's variation in both groups, but it looks like the range is shifted so that females have slightly bigger heads than males, as their range is shifted above the males on that plot. And this a lot of times, this is where you will see just a bar graph where the height shows the average. And I actually advocate against that whenever possible. I think you want students to see all of the complexity that goes into making that. And it's still very easy to read this without a statistics background. I think you're able to look at those graphs and see the difference between them, even without, you know, error bars or something like that. You can make a more traditional bar plot with error bars in DataClassroom, but our default starts you out here. And so this is maybe where you're going with one group or one use. But if you want to launch into more complex analysis, because remember that's my theme here, is start with the question, then make the graph, then move up if you want to. But if you check this descriptive stats, this checkbox over at the right, now I can start playing with things. I can do, you know, look at the mean and standard deviation, or a mean and 95% confidence interval. You can see the confidence interval is really small there. It's shrunk down right around the dot showing the mean. I could do a standard error of the mean, which is even smaller, or I can do 2 standard errors of the mean. Or one thing that I think is great as a teaching tool is I can show a mean and median all at the same time. So now for male data and female data, we're seeing the data in 3 visuals. We're seeing the raw points, we're seeing the mean and 95%, or mean and 2 SEM, 2 standard errors, and we're seeing the median and the interquartile and the range, which is the whiskers above and below the box plots. And you notice the fine print, it automatically added a caption when you put these visuals on the graph, you know, showing like the box and whiskers plot shows the median value line, interquartile range box, and full range of the data whiskers above and below. So it's tied right to the graph what you're showing. And then once your students see it this way, they can, you know, they can make decisions saying, maybe I just want to show the box plot and just show it like that, or maybe I just want to show the box plots and the dots. So they can play around with what they want to show over there on the right. And this on the right is how you manipulate anything in there. And if so, this is going to descriptive stats, which I think is actually, we don't do that enough, and we don't do it early enough. When, you know, I taught high school science, but through this job and through this undertaking, I've really gotten familiar with math standards in middle school. And I was shocked to see box plot appear in middle school math. I was shocked to see line of best fit appear in middle school math, because I was in my science teacher silo in, you know, 9th grade, 10th grade, and didn't know that students had been introduced to those concepts in math. So descriptive statistics, I think, are a great way to connect science and math. If you wanted to move up to inferential statistics, again, this button over by the appearance menu on the right, this graph-driven hypothesis test. If I click this, it will select a statistical test. In this case, it's a t-test, because we're comparing exactly 2 groups in terms of a numeric variable, this head width. And so we can calculate that. We can get our output if we want some help explaining that. You know, we can see that the question we were testing is there a significant difference in head width between the 2 groups, female and male? So it just, you know, sort of states what we were asking, helps your students interpret those results.
Aaron, a couple questions popping up as you've gone through this. So students are used to seeing a bar graph with error bars. Could you explain why you chose to represent the mean with a dot rather than a bar?
Yeah, I chose to represent the mean with the dot rather than the bar as the default, because I think it's a superior visualization, and it's more common in the real world outside of science. And I only have this perspective from the 8 years I spent as a working scientist and the 7 years I spent in the classroom. If you do want to make the error bar representation, that is available if you're in the mean based representation and you go into the appearance menu, and where it's show mean as a dot, you can show mean as a bar, and it will show it with a more traditional bar. You'll also get the warning when you're showing with a bar, your y-axis does not go all the way to 0, which is perfectly acceptable when you're representing the mean with a dot in error bars. But sometimes people can use it with bars to make little differences seem bigger than they are. And so you get that warning. You can go into the appearance and change, I can make the y-axis include 0 if I want, and it'll look something like that. But it's also, I think the bar graph is not the best interpretation for this, because in this case, I think it makes a actual meaningful difference seem not important, because the head width in terms of raw distance between male and females, it's a small, we're talking about millimeters here, but there are no cicadas that have a head width of 0 millimeters, right? There are no cicadas that even have a head width of 6 millimeters. So when you force the graph to show you 0 like this for this particular piece of biological information, I would argue it's not as meaningful. And I feel like you actually can see a lot more when looking at the data like this. But yeah, to answer your question, you can use a bar graph, but we did not choose it as the default, simply because we think students will get a stronger understanding of variation when using things like a dot and error bars to represent the mean.
And would you mind just, if you can, distinguishing what features we've used over the course of this demo that are part of the free and which are part of the paid?
Yeah, I can kind of go through that again. So working with our data sets in the library, totally free. Graphing, totally free. Adding things like error bars, connecting lines, totally free. Changing the appearance of the graph in any way, totally free. The things that are paid features, the graph-driven hypothesis test. So launching a statistical test from here, that's part of a paid feature. Using the graph wizard, which is basically taking students through the logic of what graph to make, that's also part of the paid features. Something we haven't looked at all, working with your own data, that's part of the paid features, as well as integrating with your learning management system. So Schoology, Clever, Canvas, Google Classroom, those are all paid features. And then we briefly touched on adding attachments to documents. That is part of the license features. But again, you can try those for free for 90 days. If you want to try them longer than that, let me know, and I can extend trials.
And I'll just answer another question that came up in chat. We're in the process of coming up with keys for all of the ready to teach activities in our resource library. And with special requests from any particularly compelling lessons, we can prioritize those. So if there are ones that are in high demand, we can get to those earlier.
Yeah, and I would say probably the high demand ones we already have done, but if you want an answer key to any particular lesson, just ask, and we can usually have that to you within a couple of days, if not immediately. All right. Yeah, I'm gonna, before I forget to, I just want to reiterate what I think is a really effective strategy for using graphing as this gateway to all sorts of different kinds of analyses, whether it's lines of best fit, or it's descriptive statistics, or it's inferential stats. I think begin with a graph. I really can't stress that enough. To focus on a question, and then use that graph to launch more complex analyses. So that is what I think is a winning strategy for doing these things at a lot of different levels. I hope some of the 3 examples I showed you can actually be used as examples in your classes, but there's a lot within the DataClassroom library that would also fit the bill for that. And then I also want to encourage you, if you do have any questions about working with DataClassroom, feel free to reach out. You can reach out to me personally at aaron@dataclassroom.com. If your school might be interested in a license, I'm happy to put together a proposal after we talk about details of your use case, what might fit for your school. And yeah, don't be shy about reaching out to us. We are not a massive tech company. We are a small group of really passionate data scientists, teachers, engineers, and we want to help. So please don't hesitate to reach out if you have a question. And we have about 4 minutes left, but I will say I appreciate you coming today, especially in the summer, tuning in to learn, hopefully learn something new. So thank you for coming. I hope what we have here is helpful for you and your students. But also I can hang out and answer questions as long as people want. And I will follow up by sending you a recording. We'll send you a participation of a certificate of participation if that helps you with your PD hours, and then links to any examples and resources that were mentioned during the time. So, what other questions might there be?
So this is a question that maybe you come across in your exposure to other data tools. For teachers that are looking for lessons and resources that are kind of middle school and below, and even specifically like lower elementary, have you seen any good graphing tools that really help kids visualize data?
Yeah, I don't have the answer for that. I will say this is something that interests me greatly, and we have sort of loose plans in 2022 to start working on a data classroom, especially for grades 1 to 5. So sort of a new variation. But one thing that's encouraging, I was just working with education outreach officers at the University of Arizona, and they are planning to bring data classroom to first grade, second grade, and fifth grade classrooms around the state of Arizona, because they've played with Google Sheets with classrooms at a lot of those younger classrooms, and they saw DataClassroom and they're really excited about using it to graph with kids as young as first grade. And I think the scenarios that would work well with that is if you had a data set ready to go and you could point them right to the graphing window. So they're just picking variables they're interested in, and then they're just playing with them on the control panel, flipping around what's on X and Y, making those simple, simple frequency plots and things like that. I think the areas where, and maybe you don't need me to tell you this if you're teaching the younger grades, but I think the areas where you'll run into trouble with younger kids is data formatting and taking their own spreadsheets and bringing them into the tool. I think that would require stronger scaffolding. And then the other thing is our scaffolding, like the Graph Wizard, is very text heavy for a second grader, right? You might, if you had a kid who's an advanced reader, they might be able to use it, but it's not meant for that age group. So that would possibly present some difficulties for you.
Some other questions that are coming through, just wondering if this is mobile, like iPad compatible.
It is iPad compatible. You'll need to have a fairly recent update on operating system. So I know I have an iPad 1 that hasn't had an operating system update in like 6 years. It doesn't work there, but it will work on any relatively modern with an iPad. We do have a mobile version that works on phones, and we haven't enabled it yet. We built it for a collaboration with Lab Exchange because that's a requirement for that website, that everything works on phone. But I finally convinced our engineer that it is good enough to release to the public. He's very worried because he just doesn't like how some of the visuals translate when you have it on a phone. It blew me away personally on a phone, so it will be available on a mobile device as small as a phone before the start of the school year.
A couple other questions coming through, just asking about our alignment with next generation science standards. And we have done the research, and if anyone is interested in a report about exactly how the tool lines up and supports science and engineering practices and cross-cutting concepts, core ideas, just shoot me an email, blake@dataclassroom.com, and I can send you back our analysis of that, especially if you want to share that with department heads or decision makers at your school. Another question regarding being able to upload student data and help them conduct their own research. Great part of student-led inquiry and NGSS. DataClassroom supports that in any kind of way you can imagine to be able to upload student data, whether you want to import spreadsheets, copy and paste from a spreadsheet, or just about any other way you could think to upload data.
Yep.
And a good question from Charles. This is the first of what we're calling the data science summer series. So there are going to be other webinars. And if you have some specific questions that don't match up with our programming, feel free to reach out to us, especially if you're doing a departmental professional development. We're happy to set those up as well.
Yeah. And I will send our summer schedule in the follow-up email. We have 2 in July. One is going to be put on by Kristen Doty of Catalyst Learning, and it's going to focus specifically on using data to meet standards in language arts at the same time that you're teaching data skills. And then we'll be doing one that's actually in collaboration with National Association of Biology Teachers and the Data Nuggets website. That's going to be at the end of July. I think it's July 27th. That one's going to be focused on statistics specifically. What else do we have?
I'm looking through the comments, and I think we've addressed most of the questions, but I'd say, feel free, if I've missed them, to unmute yourselves and just ask a question directly. I think our group's small enough now that it's totally fine.
Okay, and I'm going to stop my recording, and so with that, I'll just say thanks for coming. I'll stick around here after the recording is stopped. So.